Hi, I'm Murali Babu Muthukrishnan from Lithium Systems. I'm going to be talking about influencing end user media experience via device insights and analytics at scale. So we look at how you can bring new media experience to markets, and we'll also understand what are the characteristics and complexities of markets, especially the fast growing markets. And we'll look at what device insight means and what we can do in terms of the analytics at scale. We'll also talk about some of the current status and future work that's possible. So understanding the media experience, bringing media experience to market, if you look at any service provider, let's say like Meta, the ultimate goal for them is to provide engaging, crisp, and very high quality content that captures the attention of the audience. Now, the content, engaging content really depends on the content itself. But that apart, user engagement can be enabled through very high quality video, right? How good your video quality is also determines the user attention. So that can be done in many ways. One of them is to have a very high resolution video, which can be very engaging, or you have a high frame rate video when you're looking at, let's say, sports content or a fast moving content, or you can even look at higher bitrate, which can give you a sharpness, crispness to the video. And not just that, we can also bring new features through leveraging the newer compression standard. Features like HDR, the high dynamic range, or AR/VR experience with depth map and things like that. Or you may want to even bring film grain noise, where you can get that old film kind of feel to your videos. And of course, there are also other techniques by which you can build, you can bring in an inbuilt scaling experience into the standard, by which you can get the adaptive bitrate kind of experience. So, in summary, the goal is to provide very good engaging visual quality through, say, let's say like a newer standard like AV1, and with very minimal or no impact in the battery life. The user wants to enjoy the video, of course, not with the draining of the battery. So now, if you look at this whole video delivery chain, all the way from a service provider like Meta to the end user, we have four different players in this space. One is the service provider like Meta, who wants to provide engaging user experience, thereby increase their user base, and they want to do this in a very cost-effective way. Then there are these mobile chipsets. These are the uh, chipsets which enable you to run a lot of your AV capabilities. They are provided by people like Qualcomm, MediaTek, Exynos, from Samsung and iSilicon. Right? They look at optimizing their chip design and the area, chip cost in the area. Right? And they also want to make sure that whenever they do something in hardware, it stays for a long time in the market, right? So that they can make get maximum return out of the investment. And of course, they also want to make sure these hardware codecs stay for a long time. And then there's also a proliferation time. It takes for some time for the codecs to kind of become popular in the market. Right? Now, the key problem here is that there is a kind of a deadlock between the service provider and the chipset vendor. The chipset vendor would not bring any new feature unless they are very sure that the service providers are going to use it. And the service providers will not be able to bring the new features if it is not available in the hardware. On the other end of the spectrum, we also have the mobile OEMs who are going to use these chipsets and build the end devices. They are looking at how quickly they can bring good features, new features to the market. And because of the diversity that's there in the market, they will also end up creating many variants so that they can cater to the large audience. And for them, enabling new codecs or new features is very key to be able to get new customers. At the other end of the spectrum, we have the end users who want to have better visual experience, and that's what service providers are targeting. And they want to achieve that better experience with by having very minimal impact on the battery life. And of course, they also want to ensure that whenever they buy a device, it stays with them for a longer time, so that they don't have to spend again and again. So one way to be able to bring new experience, new features, is to look at the software route and not necessarily go the hardware route. So this is where understanding the market and understanding what kind of devices are there in the market really helps. So before we go into the device insights, we look at what the characteristics of the markets are, and we'll pick some of the emerging markets. So this study was done by us for Meta, especially the Meta's video infra team. So we looked at some of the uh, fast and emerging markets, fast growing and emerging markets like India, Brazil, China, right? And we picked one market, the Indian market. The Indian market has a lot of complexities in terms of the device variants that are available. The market in India is huge, several hundred million users. So there are different operating points or the price points that are available so that they can cater to the device OEMs can cater to the whole market. And then they want to create different SKUs because of this so that they can look at different segments of the market. And these queues actually create one other complexity, that is they come with different operating points in terms of the performance, let's say the codec profiles or the screen resolutions, and whether they have an hardware codec support or a software codec support and things like that. So understanding a diverse market or a fast growing diverse market like India, you need to understand the media capabilities, and that can only be done through creating a lot of insights uh, through device analytics. So a little bit more about what the complexities that we are faced with when we study such a market and try to understand what we can bring as new features into the market. We can see that even though 70 to 80% of the devices are less than 3 years old in the market, there are also devices which are more than 4 or 5 years old. So you are looking at a spectrum of devices which have been released in the last 5 years. So you need to make sure that whatever you do, you support those devices. This study was, of course, performed in 2020, 2021. So we looked at in 2020, 2021, there are devices which are released in 2015 which are still active with the users. And then in the emerging markets like India, there are many brands which make the market size. It's unlike the markets you will see in the US or in Europe, where there is domination by one or two brands, 60% domination by one brand and 20-30% by the other two brands. That's not the case here. You're looking at like 15 different brands which are very active. And if you're looking at the Android ecosystem, then because of the 5 years of the lifespan that is there with these devices, different vendors, different OEMs, you're looking at different versions of Androids being run. So when we did the study in 2020, 2021, there were 13 plus Android versions that were active. And then you also have different screen resolutions that are available in this market, right? So if you want to bring a very good quality video experience, you have to bring this at different screen resolutions. And then, of course, there are different chipset vendors that are making up this market. So you need to see how to target these different chipsets. So we look at how you want to do device insights to be able to get a grasp of this market, understand the market better, and see how you can bring your features or your upgrades to the market in a way by which you can cover the entire market. So as we looked at the market in the previous slides, device fragmentation is one of the key characteristics that we need to study. We need to look at the device fragmentation. Device fragmentation also leads to the different hardware capabilities. So we need to understand what the hardware capabilities of all these devices are. There is also software capability that varies across these devices. So you need to understand the software capabilities. And they also have different AV capabilities. We looked at how they can have different codec profiles or different codec formats being supported and things like that. So you need to understand what the AV capabilities, the audio video capabilities of these devices are, and look at the overall performance and see what kind of uh, performance you can bring by doing an analytics. So in summary, device insights can help you get the key data points that can help you bring new features and also time your upgrades for the features. And because of the complexities involved in this market in terms of the various parameters that we talked about, you need to do really at scale analytics here. That's the one which will help you determine what is one or two good operating sweet spots that you want to have for your service. So we look at how you can develop insights by looking at all these analytics parameters and how you can do analytics at scale. So as we talked about, there are multiple brands that are there in the market. You need to understand what these brands are. You need to look at the years of release, the Android versions. And you also need to categorize them into mid, high, and low tiers to understand where you want to really bring your feature. Whether you want to bring it to the high end, the low end, or the mid tier range. Then, as we talked about, there are many chipsets that are available, different screen resolutions, different battery capacities, especially when you're trying to bring some features in software. You need to be very, very conscious about the battery capacity, right? How much of battery drain is going to happen. And today, if you look at most of the mobile devices, they all have some kind of an ARM core in them. So you need to look at what the ARM architecture is, right? Because that helps you understand what kind of features you can bring. So consequently, the ARM CPU frequency, what frequency can you run? How many cores are there? Because if you want to run a software codec or you want to run a software feature, you need to look at how many cores, how much of processing capacity is there. You also want to look at what is the per core processing capacity of the ARM, because even though you have multiple cores, you may want to run your feature only on a few cores so that the application is having enough room to be able to run on other cores. So if you look at this gamut of characteristics, you need to analyze all of these to be able to arrive at an operating point, the optimal operating point for a service provider. What is the right resolution that you want to pick? What is the right frame rate you want to pick? What is the right bitrate you want to pick? And of course, the coding tools and also the profiles that you want to support. All of this is only possible when you can do large data analytics of the parameters. So one such study that we did for Meta was to look at what would it take to be able to bring a new standard like an AV1 in software on the devices. By doing this, you can actually provide better video quality and, of course, consequently, better user engagement. So we picked 61 devices, which were a representative set of the entire market. They were categorized into 30 high-end devices, 14 of the mid-range, and 17 of the low-end. And different screen resolutions were part of this mix. And about 50 devices were having the latest ARM V8 architecture, and 10 devices were from the ARM V7. Of course, there are 15 brands that we talked about and several different Android versions. The high, mid, and low category was categorized based on the ARM architecture, whether it was V8 or V7, and also what kind of ARM core was there. Is it A7 and A55X plus? Then it is called high end. If the A53 that was there was having a clock frequency of more than 1.8 gigahertz, it was called the mid tier, and anything less than that was called the low tier. And of course, the V7 architecture. So we also looked at what kind of tests we need to do to analyze and what kind of data we need to gather. One was to look at the real-time capability of these devices, real-time analysis, playback analysis. So you want to see whether the video plays in real time. When you say real time, it should have no frame drops, no frame skips, right? And it was considered as passing real time test if it was dropping less than 2% of the frames that were available. And also we want to look at the CPU usage. CPU usage in terms of how much is the software is loading up the CPU and what is the CPU available for the other task. So the average value taken of the CPU usage is used as the final measure for this. And the other one we did also was to look at the battery usage, right? How many hours of playback was possible with this software coding. So we looked at 5 different resolutions: 270p, 360, 540, 720, and 1080. 2 different frame rates, different bit rates through the QP points, the operating QP points. And then we also looked at 2 different configurations of the AV1 software itself, especially the SVT AV1 software, which had one particular feature called the tools of, which enabled the decoder to have lesser complexity compared to the other case of the tools of. So we are really looking at uh, big combinatorial tests here: 5 cross 2 cross 9 cross 20 data points, about almost 1800 test points. So you need to have these many test points to be able to see what would be the behavior of software or the feature that you're trying to bring. Let's say the software AV1 codec. When you run this uh, decoder across different devices. So the setup that we had for analyzing this was to have the mobiles connected either through a USB hub or the PCIe to a PC, and all the tests were launched from the PC into the mobile device as if it's like downloaded and played. And then we are collecting all the log information, logging all the information to be able to do analytics either on the device or on the cloud. We also, because these are all uh, very valuable data points that we are generating here to be able to understand the market, to see what kind of tests can be performed, to understand what features are possible. You need to make sure that all of this data is well protected. So we had a centralized server through the firewall, enabling a lot of data protection using a separate network. Hosts were secured with the DLP. The systems are protected with the Symantec endpoints, and we had the automated system backup. So it was a very secure and safe environment by which we are collecting this data. Now I'll play a small video to be able to understand how these tests are done online. Yeah, so you have an interface by which you can log in and look at the devices that are available. So at the time of recording this video, we had like about 40 devices connected across two different geographies, and then you can go and select what kind of device you want to the group you want to pick, and then you have 4 devices connected to this group, and you can go and pick one device and look at it. So remotely you can access the shell to be able to run some of the commands, and of course you can also see the video being played there. So the video which is being played, and a lot of information is being collected about this video as it plays, right, in terms of what we talked about, the real-time playback capacity, what is the battery drain capacity, and what is the CPU usage and things like that. So this kind of gives you a very nice and easy interface by which you can run your tests and collect the data. So different clips are played in a loop back to be able to look at the characteristics. Right, one sample analytics is what I'm showing on the screen now. So we can see that there are about 46 devices which were able to do 1080p 30 in real time. Right. So of course the aim of this presentation is not to talk about the results, because that's a separate topic by itself. But the idea is to show how through these kind of device analytics we can arrive at some of the results. So as I mentioned, we looked at different frame rates for 60 FPS. We have different characteristics that we are seeing, that for 540p, almost 52 devices are able to play 540p 60 in real time, and whereas when you go to 1080p 60, it's only 23 devices that are able to play that. And if you look at 720p 30 itself, all the devices are able to play. So that's probably an operating sweet spot. And 1080p 30, there are only 50 odd devices that are able to do 1080p 30 in real time. We also studied the battery capacity. So if you look at it for a 720p 60 playback, the average battery capacity was like you can do 11.5 hours of playback, and for 1080p 60 it was about 8 hours of playback time at a battery capacity of 4000 mAh. So we also did another analysis where we wanted to study what kind of codecs are available either in the hardware and software uh, on, on these devices. So we picked about 300 devices to understand this, because this covers the entire or a large part of the world market, right? So what we found was that through these analytics, that AVC, the S.264 standard, is prevalent in hardware, and it supports 720p 60 and all the lower ones. And almost all devices support AVC hardware playback. HEVC was having 95% market penetration of the devices that we looked at. And VP9 hardware penetration was about 70% in the market. As I said, some of these analytics that we have done and the results of these analysis have been published in other conferences and forums, uh, one at SPIE, and also there is a meta blog which talks about how the AV1 software codec was analyzed and what were the results of it. So as I said, the focus of this talk is not talk about the results, but to talk about the framework and the setup and how you want to go about doing analytics to be able to arrive at the operating sweet spots, the profiles that you want to support, what features you want to bring on your platform. We look at some of the current status. The current status is that we have about 480 plus devices in the lab, through which you can do a wide range of market study, whether it is India market or some other market or even the world market. You can do a large study of all these devices, and we continue to do a lot of continuous analytics. If you want to bring new features, if you want to bring new upgrades, a continuous study or continuous analysis of the market should be done. This is one example of how we continue to upgrade the device analytics, the lab as well as the framework to be able to do more and more analytics. I talked about how we did initial analysis with 300 devices, then we did another analysis with 60 devices. After that, we also added 170 more devices. That's where you see the number close to 480, which was used to, along with 130 devices from the previous set, was used to study what is the behavior of hardware codecs, especially when it comes to real-time communication like a video conferencing or things like that. So we looked at hardware codec stability in terms of memory leaks, their performance. Also looked at what kind of bitrate deviations that are there. You say you want to encode a 2 Mbps, is it within 2 Mbps or is it 2.5 Mbps? That kind of analysis we do. We also looked at what is the encoder compression performance compared to, let's say, a software codec. How good was the encoding capability of the hardware encoder compared to software encoder? And we also looked at the latencies and time and the initial decoder delays, because that kind of is very important in a real-time communication scenario. So in all, we have done a lot of study, continuous study, and having this kind of a setup and a framework has really enabled us to be able to do this study and arrive at the key decisions that will help you guide to bring new features, new software, new capabilities into your service. Right? There is a lot more scope we can do with this kind of a setup. You can understand device fragmentation in a continuous way. You can also understand how the user experiences in terms of whether there's buffering, caching happening, how is the delivery happening, or you can even look at, if you want to bring some new features, let's say like a HDR, you can really go and study how many of these devices are supporting HDR and how many of them are not supporting, and what does it take to even bring such a support on the software. And then this also gives you a lot of feedback for you to be able to understand what kind of infra I should have and what kind of ROI can I have on this infra and what kind of efficiencies I can expect out of this infra. So it kind of gives you feedback on what encoding recipes you should operate, what transcoding recipes you should operate, so that you can get the best out of your infrastructure, and also you give the best to the user in terms of the user engagement. So in summary, these data insights and analytics can be done for any decoder characterization, encoder characterization, or even the hardware software partitioning and characterization. So we can look at multiple standards and also look at what kind of playback capabilities are there, what kind of CPU load does it have, what impact does it have on the battery, and look at what kind of upgrades you can bring. As I talked about, we can also look at what kind of special features that you can add to your service by looking at the specialized services or features like HDR and higher frame rates. And you can also do some very focused study in terms of how the proprietary or open source components are behaving on a device. And of course, the framework is set up to do analytics at scale. And as I showed in the video that was played, it's a web-hosted interactive service that can enable you to do a lot more analytics and data gathering. Thank you.